Hey y'all. Today's objective is power functions. And we've been going over lots of functions, so now this is the big umbrella that's called a power function. An example of a power function might be the volume of a sphere, 4/3 pi r cubed. Or if we're doing quadratics and we're talking about gravity, you normally would start with negative 16t squared. These are just examples. You've seen power functions, we've done power functions, so now I'm kind of just going back, showing you all of these can be written as a type of power function. So there are two categories of power functions. There's going to be a direct and an indirect, kind of like a direct variation, indirect variation. So if it's written like this, y equals kx to a power. K and p are constants, like y equals kx to the power. And this is a direct variation if this is written in this form. Now, we have seen this. We just did inverse variation, y equals k over x. Well, this can be rewritten as a power function if you bring the x to the top and you make it a negative power. So this is an indirect variation or inverse. So you have both our power functions. One is direct and one is inverse or indirect. So like an example would be the temperature in the oven and the time to cook cookies. So the temperature that you set your oven to and the time that it would take to cook your cookies, that is going to actually be inverse or indirect, because if your temperature, the oven temperature, is higher, then the time is going to be smaller. So you can see one is increasing, one is decreasing. So that is not a direct proportion, that's going to be indirect. If the harder you hit the ball and the farther it travels. So the harder you hit a baseball and the distance it travels. So if you go to the plate and you hit the baseball really, really hard, then it's going to travel farther. So the increase in strength and the increase in distance, that would be direct, meaning they both are increasing. So when you see word problems, you're going to have to decide, is it going to be a direct or an indirect, and then what kind of power function you would use. So here are 6 special types of power functions, which you've seen almost all of them. I think maybe one might be new, but we've seen x squared and we've seen x cubed. So a cubed and a square function. We've also seen an inverse variation. Now this one is new, when you have x to the negative second power. It's like the parabola 1 over x squared. And this is what the graph ends up looking like. Of kind of a variation of this and this to make this. We've done a square root function and we've done a cubed root function. Notice I didn't write it with a radical because it doesn't follow the format of a power function, but these are equivalent. And then here you have a cubed root, it's still a power function. So here are the 6 most special cases. These are going to be kind of like our parent functions, and then if we transform them, but the only new one might be this one right here, so make sure you get that down. Okay. And then here is some special information about similarities. For example, if you have x to the p power and it's an even power, so 2, 4, 6, 8, it's going to act like x squared. It means it's going to be some sort of parabola. It's going to have a very, it's going to vary a little bit, but it's going to act like this. If you have an odd function, it's going to act like x to the 3rd power, and so forth. So copy these down, and then be ready. We're going to investigate power functions in class tomorrow.